There are various types of redox reactions which are included. We can classify into the different parts. The very first, if you'll see, I have written intermolecular redox reaction. On to the other side, I have written intramolecular redox reaction. Disproportionation reaction, comproportionation reaction, and some reactions which do not involve any change in the oxidation state is what non-redox reaction. So basically, when we talk about redox reaction or its types, then basically there are 4 types of redox reaction, and we can say it's intermolecular, intramolecular, disproportionation, and comproportionation. Now, what are the tricks and what are the methods that we can identify any reactions as any one of these reactions? Again, the answer is same, student. We have to first find out the oxidation number, and after finding the oxidation number, we have to just relate the oxidation number onto the left hand and right hand side, and on that basis we can identify which type of redox reaction it is. Let's talk about the very first reaction. If you'll see this reaction where SnCl2 reacts with FeCl3 and it gives SnCl4 and FeCl2. Now we all know that the things which are written on left hand side are called reactant, and the thing which is written onto the right hand side are called as what, products. So if we'll just check the change in the oxidation state of reactant and product, so it is like this. So first we have to check the oxidation state. In SnCl2, you will see the charge of Sn is +2. But when SnCl2 converts to SnCl4, the charge is +4. So here if you will see, the +2 is converting to +4. What do you think? Is it increase or decrease in oxidation state? Yes, student, it is increase in oxidation state. Since the oxidation state in this case increases, that's why this process is referred as oxidation half reaction. So SnCl2 undergoes oxidation half reaction. But if you'll see the other reactant, since it is consisting of more than one reactant, so if you'll see FeCl3, the charge of Fe is +3. And FeCl3 converts to FeCl2. Here the charge is +2. Now we all know that +3, the higher charge, ends with ik, and +2 is referred as what, us. So Fe +3 converts to Fe +2. So here the process is reduction half reaction. If you will see the pattern in this reaction, there are 2 reactants. One is undergoing oxidation and another reactant is undergoing what, reduction. So in a chemical reaction, which is a redox reaction where both the reactants are participating in the redox reaction, one is getting oxidized and the other reactant is getting reduced, then such type of reactions are referred as intermolecular redox reactions. We'll see the next one. In this equation, student, let us find out the oxidation state of all. There is only one molecule onto the left hand side. Can I say there is only one reactant, student? It is potassium chlorate. So if you will see the potassium, since all group 1 metals have the charge of +1, and here the oxygen, it's oxide. Generally for oxygen we take oxidation state of -2. Here if you will see the charge of chlorine, it should be +5. Now KClO3 is undergoing decomposition since there is one reactant and is giving 2 products. So here the charge of potassium does not change. Please remember, if the charge of any chemical species in redox reaction does not change, so that species is referred as spectator ions. You got this? That is referred as what? Spectator ions. But if you will see the change in the oxidation state of Cl, onto the left hand side the charge is +5 and it is becoming what? -1. Here it is O2, it's a molecular oxygen and the charge will be what? 0. Right now we are not discussing the balancing of the equation, student. We are just checking which type of reaction it is. So in case if the reaction is not balanced, please neglect it. So if you'll see here, in the same molecule, two different atoms. For example, the chlorine is +5 and it is becoming -1. So chlorine is undergoing reduction half reaction. But you see the oxygen is -2 and it is converting to what? 0. So this process is oxidation half reaction. So two different elements of same molecule, one is undergoing oxidation and one is undergoing what? Reduction. Such type of reactions are referred as intramolecular redox reaction. Now next is, if you see this reaction, hydrogen peroxide, very famous compound. In hydrogen peroxide, student, the charge of the oxygen is what? It's -1. In peroxide we know that the charge of the oxygen is -1. But when H2O2 decomposes, it gives two products, that is H2O and O2. So oxygen is present in H2O also and O2 also, but if you check the oxidation state, so in H2O, the oxidation state of oxygen is -2, it is oxide, and this is the elementary form. In the molecular form, the oxidation state is taken as what? 0. So in this case, student, the same substance, if you will see that H2O2, the change in the oxidation state of oxygen from -1 to -2. If I am comparing H2O2 to H2O, so there is decrease in the oxidation state, and this process is reduction half reaction. But if I am comparing H2O2 to O2, then change in the oxidation state from -1 to 0. So there is increase in oxidation state. So this substance, this reaction is what? Oxidation half reaction. Can I say, student, the same substance is undergoing reduction as well as what? Oxidation. So same substance will act as oxidizing agent as well as what? Reducing agent. So in such cases where for same chemical species, you will find three different oxidation state. I repeat, in a redox reaction for same chemical species, if you're finding three different oxidation state, one on left hand side and two on right hand side, then that reaction is referred as disproportionation reaction. Please remember, the substance which undergoes disproportionation reaction or disproportionate act as oxidizing as well as what? Reducing agent. The same substance is acting as what? Oxidizing and reducing agent. The trick to identify the disproportionation reaction, the same element should have three different oxidation state. Onto the left hand side, it should have one oxidation state, and onto the right hand side, it should have two different oxidation state. Next reaction, if you'll see, this reaction, student, PB and PbO2, there are two reactants and they are forming one product, PbO. It's like combination, as there are two reactant is giving one product. So if you just check the oxidation state, Pb, since it is present in the elementary state, the charge will be 0. In PbO2, generally the oxygen is taken as what? Oxide, it's -2. So the charge will be +4. And in case of PbO, the charge of Pb is what? +2. So if you'll see, there are two different reactants, but there is one element which is common. Here, the Pb is common. So if the Pb is related with the PbO, so there is a change in the oxidation state 0 to +2, which is oxidation half reaction. And if it is PbO2 to PbO, that is +2, so it is referred as reduction half reaction. So in this case, if you'll see, Pb, the same element is having three different oxidation state, but onto the left hand side you will find two different oxidation state, and onto the right hand side you will find one oxidation state. It is just reverse of above reaction, that is disproportionation reaction. So this reaction will be referred as comproportionation reaction. Please remember, disproportionation reaction can be remembered it like this, that it's like decomposition reaction, where onto the left hand side you will find one oxidation state, and onto the right hand side you will find two different oxidation states. In comproportionation reaction, it can be similar like combination reaction, where left hand side you will find two or more than two oxidation state, and onto the right hand side you will find what? One oxidation state. At last, student, if you'll see, it's a type of neutralization reaction, very common reaction. Here if you'll see, the charge of Na is 1 plus onto the left hand side, and again 1 plus. So can I say it's a non-redox reaction? Oxygen is generally -2, and again it is -2. So oxygen is not involving in non-redox reaction. Hydrogen is +1, and again it is +1. So hydrogen is also not involving in non-redox reaction. Cl is -1, again the Cl is -1, so it is non-redox reaction. So if you'll see, all the chemical species in this reaction does not involve in redox reaction. So this reaction is referred as non-redox reaction, as there is no change in the oxidation state. So all the species like Na plus, H plus, Cl minus, O2 minus, all these are referred as what? Spectator ions. So on the basis of change in the oxidation state, we can define or we can classify redox reaction as above types.